All right, guys, today we are going to take a look at lesson 9.2 on simplifying square roots. So go ahead and open up there in your notes. So the past couple days we've been talking about square roots and a sort of introduction to them, and now we're going to today tackle simplifying them. So first of all, we need to know, what does it mean for a radical expression or a square root expression to be in simplest form? All right, well, there's two main things that have to be true. In order for it to be in simplest form, no factor of the expression under the radical sign can have any perfect square number other than 1. In other words, the number that's under the radical sign can't have any factor that is a perfect square. And I think that'll make even more sense to you once we start doing some examples. The other thing that's true is that there can be no fractions under the radical sign and no radical sign in the denominator of any fractions. And so if there's any fractions that are under the radical sign, we need to get rid of those in order for it to be in simplest form. All right, then notice the note here that for the sake of complexity, all variables in the radical expressions we're going to assume are going to be non-negative numbers. In other words, if it asks you for the square root of, look at that example below, AB, you're going to assume that A and B are not negative numbers, because we already talked about how we can't take the square root of a negative number, so we're going to assume that all of those variables have to be positive numbers in order for this to work. All right, so then as you're looking at that box down below there, you see that this is the product property of square roots. And what it says is that if we have the square root of A times B, we can separate that into the square root of A times the square root of B. And so that helps us when we're simplifying, because so 9 times 7 is obviously 63. So if we had the square root of 63, so pretend like we had the square root of 63, what it's saying is we could write that as the square root of 9 times 7, and then we can split that into the square root of 9 times the square root of 7. And the reason that that helps us is because 9 is a perfect square, so we can take the square root of 9, it's 3. And so the square root of 63 simplified would be 3 times the square root of 7. All right, now hang with me here, because it might take a couple examples of this for you to catch on and understand. So don't panic if after the first couple it feels a little confusing. All right, so let's look at example 1. Let me also encourage you that if you don't have your calculator out, you definitely want to get that out. It's going to help you in this unit here. You can use, or in this lesson, you can use your calculator in your notes, and you're welcome to use your calculator on today's homework assignment as well. All right, so to simplify the square root of 150, I am trying to look to see, are there any perfect square factors that go into 150. Now, to do that, we need to remember what are the perfect squares. And in fact, I would encourage you to make a list at the top of your sheet. We'll make a list right here, but definitely when you do your homework, it'll be helpful to you to maybe just have a list at the top of the page that you can refer back to. All right, so 1 times 1 is 1, 2 times 2 is 4, then I have 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and obviously they keep going because that's 12 times 12, but you could do 13 times 13 and 14 times 14, but this is probably going to be enough to at least get you started here. All right, so one of the easiest things, like maybe one of these pops out as out at you as being a factor of 150, but if not, then the easiest thing to do is just say, does 4 go into 150? Does 9 go into 115? Does 16? And your goal is you're trying to find the biggest perfect square factor that goes into it. So maybe it jumps out at you that 25 is a factor of 150. And so instead of writing this as the square root of 150, I'm going to write it as the square root of 25 times 6. Since 25 times 6 would be 150. And then the product rule that we just talked about means that I can split this up into the square root of 25 times the square root of 6. Well, the square root of 25, that 25 is a perfect square. That's why we broke it into that. And so this would be 5 times the square root of 6. And that would be the square root of 150 simplified, because 6 does not have any perfect square factors besides 1. All right, let's look at example 2 now. All right, in this one we have a number and we have a variable. Let's focus on the number first. So we have 18. Again, we're going back and looking at this list of perfect squares that we made at the top of our page here. And we want to figure out which perfect square is a factor of 18. Well, this is a little bit of a smaller number, so hopefully it's a little easier to notice that 9 is the perfect square that is a factor of 18. So I'm going to write 18 as 9 times 2, and then I can't forget that t squared there. So just like before, I'm going to break this into its own square root. So I have the square root of 9 times the square root of 2 times the square root of t squared. All right, well, the square root of 9 is 3. The square root of 2 is not a perfect square, so I'm going to leave it just like that. Now we have the square root of t squared. Well, if you remember from yesterday's lesson, we talked about how we can undo something that's squared with a square root. So the square root of t squared is just t, and that comes out of the radical because we've taken the square root of t squared, and that's t. And so the best way to write our final answer here would be you want to put everything that's outside the radical sign first, and then everything that's under the radical sign. So this one would be 3t times the square root of 2 in simplest form. All right, let's go to the next page and do some more examples. Since I'm on a new page here, I'm going to go ahead and at the top real quick make my list of perfect squares again, because it's just nice to have that to be able to refer back to. So I would encourage you to make this list at the top as well, and I would do this on your homework page just so you can keep looking back at it as you go. All right, so 75, I'm looking for what perfect square is a factor of 75, and I know that it is 25, and so 25 times 3 would be 75, so I'm going to break this into the square root of 25 times the square root of 3. The square root of 25 is 5, so that comes out of the radical sign. The square root of 3 is not a perfect square, so that stays underneath. And so the square root of 75 in simplest form would be 5 times the square root of 3. All right, let's go on to number 2. All right, here we have 80, and maybe one of these doesn't jump out at you right away, but you can start going through the list. And what you would notice is that 4 is a factor of 80. However, there is a perfect square bigger than 4 that is also a factor of 80. And you want to try to find the biggest perfect square that goes into it, and I'll explain more about why that is in just a second. So as I keep going down the list, I'll notice that 16 times 5 equals 80. So I could write 80 as the square root of 16 times 5. So this is the square root of 16 times the square root of 5. The square root of 16 is 4. Again, that comes out of the radical sign. One mistake people make is they'll take the square root of 16 and then the square root of 4. As soon as you take the square root of 16, that square root sign is gone. It's just 4. So this would be 4 times the square root of 5 as your final answer. Now, let me show you what would happen if you used 4. So if you said that 80 was 4 times 20, that would be true. That is a true statement. And we could split this into the square root of 4 times the square root of 20. The square root of 4 is 2, so we would have 2 times the square root of 20. Now, that is mathematically correct. However, the problem is 2 times the square root of 20 is not in simplest form yet. And the reason that it's not in simplest form is that 20 still has a perfect square factor. And remember, you're not in simplest form until the number underneath the radical sign has no perfect square factor. So if I had done it this way, I would need to keep going and say that 20 could be written as 4 times 5. So this would be 2 times the square root of 4 times the square root of 5. The square root of 4 is 2, and then I have times the square root of 5. 2 times 2 is 4 times the square root of 5. And what you should notice is that we end up getting the exact same answer that we had the first time. It's just it took a little bit longer because we didn't find the biggest perfect square first. And it's totally fine to do it that way. You just need to understand that it's going to take you a few more steps. So it's always best if you find the biggest perfect square factor that goes into that number. All right, let's go on to number 3. The number 24 I'm going to focus on first. I'm trying to find the biggest perfect square that goes into it. And that would be 4. So I have 24 I can write as 4 times 6. And then I can't forget that r squared. So this would be the square root of 4 times the square root of 6 times the square root of r squared. So the final answer here would be 2r, again, because the square root of r squared is just r, and I want to bring that to the front before what's underneath the radical sign, times the square root of 6. All right, why don't you take a minute, pause the video, and try 4, 5, and 6 right now, and then when you're ready to check your answers, press play again. All right, go ahead and check your answers with 4, 5, and 6. Again, on some of these, for example, like number 5, you might not have known right away that 36 went into 180, but the best thing to do is just to go down that list. Do 180 divided by 4, 180 divided by 9, 180 divided by 16, 180 divided by 25, 180 divided by 36 until you find the biggest one that goes into it. And that's why having that list at the top is helpful to you to refer back to. All right, now you'll notice that down below I added a 7 and 8, and that's because so far all of these problems, the variable has been squared in each of them, and that's a little easier to do because we know the square root of m squared is just m, the square root of n squared is n. But what if it's not squared? I want to look at just a couple of those because those could be in your homework as well. So number 7, we have the square root of 50x. Well, we first look at 50 and we know that that could be written as 25 times 2, and then we have times x. So this would be the square root of 25 times the square root of 2 times the square root of x. Well, the square root of 25 is 5. The square root of 2 we don't know. And the square root of x, we can't bring that x out because it's not x squared. So it has to stay under the radical sign because it's not a perfect square. And so the answer to this one would be 5 times the square root of 2x. That x stays underneath the radical sign because since it's not squared, we can't take the square root of it. Okay, now look at number 8. Okay, so 32 I can write as 16 times 2. Now, x to the third power, I'm going to write as x squared times x. And the reason I'm going to do that is an x squared I can pull out. So I want to get something I can pull out. Remember, I want anything that can be pulled out of that radical sign you want to. So I'm going to split that x to the third power into x squared times x. Okay. So then this would be the square root of 16 times the square root of 2 times the square root of x squared times the square root of x, which would be 4 times the square root of 2. Now the square root of x squared, that x gets to come out, but the square root of x, that has to stay underneath, okay? Because we can take the square root of x squared, but we can't take the square root of x. And so then the final answer here would be 4x. Remember, anything outside the radical sign comes first. And then underneath the radical sign, we still have a 2x. Okay, so I wanted you just to see a couple examples where the variable might have had an exponent other than 2. All right, the last property we're going to look at today is the quotient property of square roots, and it's very similar to the product property. It just says that if you have a quotient, you can split it into the square root of the numerator times or divided by the square root of the denominator. And you see a couple examples there, and we'll look at a couple more examples here in just a second. All right, so in example 3, we have the square root of 17 over 25. And what that product property, or that quotient property just told us is that we can take this as the square root of 17 divided by the square root of 25. Well, 17 is a prime number, so it has no perfect square factors, so that just stays as the square root of 17. There's no way to make that simpler since there's no perfect square that is a factor of 17. The square root of 25, though, is just 5, since 25 is a perfect square, and so the square root of 17 divided by 5 would be this in simplest form. And again, if you look back to our descriptions at the very beginning of this lesson, we said that there just can't be a fraction under the radical sign, so we took care of that, and there can't be a radical sign in the denominator, and we took care of that because in the denominator is just the number 5, so this would be in simplest form. All right, let's try a couple more. So in number 1, I'm going to write this as the square root of 15 over the square root of 16. All right, so I've got to look at 15 and make sure there's no perfect square factors that go into it. Well, 4 doesn't go into it, 9 doesn't go into it, and 16 obviously doesn't because it's bigger than that. So we'll just leave this as the square root of 15. The square root of 16 is 4. So we always want to take that square root, and so that would be my final answer. All right, let's try another one. Number 2, I'm going to write this as first the square root of 32 over the square root of n squared. All right, well, 32 could be written as 16 times 2, since 16 is a perfect square. And then over here I have the square root of n squared. All right, so this would be the square root of 16 times the square root of 2. The square root of n squared is just n, so I can take that square root. And so the final answer would be 4 times the square root of 2 over n. And that would be simplest form for this square root. All right, let's try number 3. So I've got 32 again, so I'm going to write this as 16 times 2, but now this time I have times y squared over the square root of 81. All right, so that's the square root of 16 times the square root of 2 times the square root of y squared over, in this case, 9, because the square root of 81 is 9. And so this final answer here would be 4y times the square root of 2 over 9, because I took the square root of 16 and the square root of y squared. Those both come out of the radical sign. The 2 is not a perfect square, so it stays under, and then it's all over 9. Now, the other thing you need to be careful of is if there's anything outside the radical sign that could simplify, you need to do that. 4 and 9 can't simplify anymore, so we're good there. But if it could simplify, if that had been a 4 over an 8, you would need to simplify it to 1/2. We'll get to one of those in just a minute. All right, why don't you try 4, 5, and 6? So pause the video and then press play again when you're ready to check. All right, so go ahead and check your answers with mine. I want us to look at number 5 real quick, because 5 is about as difficult as the problem is going to get. So you'll notice first that on the top, when I had 45, that I split that into 9 times 5, since 9 is a perfect square. And then on the bottom, I had 36y squared, so I split that into the square root of 36 and the square root of y squared. Well, on the top, I got 3 times the square root of 5. On the bottom, I got 6y, because the square root of 36 is 6 and the square root of y squared is y. All right, so here's an example of one where I had something that I could simplify outside the radical sign. If it's under the radical sign, you can't mess with it. But if it's outside the radical sign, if you can simplify it, you need to. So 3 3 over 6 simplifies to 1 over 2. So I need to do that simplifying because, again, my whole point here is to try to get this into simplest form. Now, just so you understand, you could put that 1 there, or technically you could write it without the 1 as just the square root of 5 over 2y, and that would be fine as well. I don't care if you put that 1 there or don't put that 1 there. In number 6, because the 4 and the 7 can't be simplified any, then it was in simplest form. But if it could be, you always want to make sure that it is as simplified as it could be. All right, the last thing I want to point out to you before we wrap up today is let's look at number 4, just because that was a little bit of a simpler one. We just had the square root of 50x squared. All right, now sometimes people ask, well, could I split this into the square root of 5 times the square root of 10 times the square root of x squared? Okay, well, mathematically, that's fine. Obviously, 5 times 10 is 50. But hopefully some of you are starting to see what the problem here is. 5 is not a perfect square. 10 is not a perfect square, so that hasn't helped me make this any simpler. So whenever you're breaking it into a factor pair, you want to make sure that one of them is always a perfect square, because otherwise it's not helping you get it any simpler. Okay, so this is not mathematically wrong, but it is simply not helpful to us in the process of simplifying. All right, hopefully this helped you understand how to simplify square roots. This is a skill that we will be using almost every day for the rest of this unit.